let's get started. So hey, my name is Markus Laaksonen, and I'm the Palo Network SC from Finland, covering Finland and Baltics. Thanks for coming for this session, and hopefully you have had a good day so far. A lot of interesting sessions. I will cover today a little bit about our endpoint, so advanced endpoint, so what we are now bringing to the endpoint side. So I will also cover a little bit about how this will fit in the bigger picture, so how this will basically integrate with our firewall, with our threat intelligence cloud, and how it will fit to the bigger picture. So not just another silo, another endpoint product which is doing exactly the same as the other ones. No. As Palo Alto always, we've been doing stuff that's a little bit different, so basically seeking stuff that's new ways to do things. So not only always just copying what other guys are doing and then later on saying that we have the same as the other guys. No, we want to do it a different way, so we are checking what's actually the right way to do it. And like the traps as well, traps is something that Palo Alto is building. So we acquired a company called Cyvera last spring, and from there we started to basically integrate the product to our rest of the portfolio. But basically this is now built by Palo Alto Networks, so it's one of the products that basically was built from scratch for today's market, like the firewalls as well. Before we go to the actual market or the actual product, so when we check for the reality what we are facing today, so what we are seeing is that when we are checking for the attackers, for example, what we are seeing is that they are more sophisticated and well-funded. So basically they have better resources than they have ever before. And what we are seeing there is that in 2013, for example, we saw a 91% increase in targeted attacks. And these are the most difficult ones because these are targeted against some customer. For example, we have the use cases. Target was there, one of them. Some time ago, RSA was one of them. So these are targeted attacks which are against that customer. I will talk about how it's difficult to basically block those with the traditional mechanisms. And when we are talking about the zero-day stuff, so when we are talking about the new stuff, like I said, what we are seeing is that it's more and more new stuff the guys are using. Because they have better resources, they have more money to use. What they are actually using is that they are discovering more the vulnerabilities today. So what we are seeing is that most of the exploits we are actually seeing is using vulnerabilities that are less than 2 years old. Some of them, like I said, when we are talking about the APTs and the zero-day attacks, those are using the vulnerabilities that we don't even know that exists. But we still need to have some protection, and we need to be able to block those. And that's difficult, but we can cover that one. And then we talk about the endpoint. So why the endpoint? So we've been already doing the stuff on the network level. But what we are seeing is that 71% of all the breaches that has happened has been using the actual endpoint device. And there's always mechanism to bypass any basically network device. One mechanism, for example, is just to use the USB stick. If the traffic never goes through network, it doesn't matter how much hardware and what kind of devices you have on the network side. If the user picks up a USB stick, plug it in, use that one, the exploit is already on your computer or your device, and you are screwed. So we need to have a way to block that one. What we are seeing, the numbers, these are not something we are just basically throwing the numbers. These are actual from different studies. For example, there's the Verizon data breach studies and other ones. What we are seeing is when people are using those basic detection mechanisms, AVs and those, what has happened is that the malwares and the actual bad stuff can live on your network for a long period of time before you figure it out or somebody else. So if you think about the average time for detect some targeted attack is 225 days. So it's a really long time, meaning that the malware can basically gather as much information as it wants, because this is more than half a year. And also what's really worrying is that 84% of all these attacks was not covered by or found out by that company itself, but some third party, like for example FBI, NSA, some government who theorized, or some European government seeing that, hey, there's something nasty in your network because we are seeing this and that customer didn't have any clue what's happening on their network. So it's really, really scary. Well, one thing we can all agree probably is that the antivirus and the signatures in that sense is something that is dead. So all the antivirus vendors are now saying that just using the signatures is not the right approach. And the problem is that you need to see it before and you need to build the signature. So basically when we are talking about this unknown stuff, we are talking about the targeted attacks. We don't have any signatures for those. So basically a signature is not the way to go, and that's not the future way to do things. When we talk about the actual bad stuff, malwares and exploits, there's basically two different mechanisms the bad guys can get control of your device. The first one, which is the easier one, is the actual malware. So basically sending you an executable. Get the user to download the executable, get the user to download the executable, and get the user to run that executable. It could be that it seems like a valid executable, but there's something inside and something happens. And once the user runs that executable, the actual malware code is basically installed to the device itself and getting the control, and from there gets the full connection to the internet and then can basically send the information, and that's basically compromised device. Another, the more sophisticated way to do it is when we are talking about the exploits. When we are talking about the exploit, we are talking about some vulnerabilities, some holes, some flaws in code, in programs. For example, it can be Microsoft vulnerability, it can be Adobe, it can be a Word document vulnerability, it can be in the browser, meaning that the user is doing legitimate stuff. For example, the user is browsing to some web page. The user doesn't realize that something is happening, but when he or she goes to the web page, there's an exploit that uses a hole in the browser and takes the control. That exploit will use those exploit mechanisms, take the control of that device, and from there on we can control the device as it would be ours from the cloud, so the bad guys. So it's the exploits are the really difficult ones. The common problem for all the endpoint products, if it's an AV, if it's some endpoint solution, has been is that they are using these signatures. They are using these heuristic engines, so they are getting those daily signature updates. Like I said, that the problem with the signatures is that you need to see it before you can build the signature. So if we are seeing some stuff only once, like a targeted attack, let's say, for example, against RSA, it was an email that was sent. Nobody has seen that email before. There's no signature available for that threat, for that attack. So it's basically none of the AVs, none of the devices were able to basically detect or block that threat. Like I mentioned earlier, is that there's always way, we are doing some stuff on the network level, we are doing the scanning, so we can analyze the unknowns that what we are seeing on the network level. But the problem on the network level is, like I mentioned, that there's always way to bypass the network device. It can be that we are using the USB stick or some removable media. It could be that we are sending encrypted traffic, not using SSL, not using TLS, but some proprietary encryption. There's no way, nobody can basically touch that connection. It's going through the firewall, it's an encrypted tunnel. Or we can send it in small pieces, for example, in 3 weeks. Send first part this week, next one next week, and the last part in 2 or 3 weeks. There's no sandbox ways to basically detect or block that. There's always way to bypass the firewall, bypass the security level. I'm not saying they are useless. They have a big role in this basically platform idea, but it's not necessary. It's just not enough. We have to also concentrate on the endpoint. Like I mentioned, that when on the Palo Alto networks, we decided that there's some time to do something for this. We started to figure out that what we can do better on the endpoint, how we can do it differently than what all the other AV vendors are doing at the moment on the endpoint side. So what we saw is that, what are the key things that the actual agent or the endpoint product must be able to do? So the first one was that we need to be able to prevent all the exploits. It doesn't matter if it's a known exploit, if it's an unknown exploit. So when we're talking about real zero-day exploits, we need to be able to block those from the first time we are seeing, not doing any analyzing, not causing harm to the user, but block it from the first time we are seeing it. Also the same for the malware. So when we are able to block the exploit, we need to also concentrate on the malware. So meaning those that what the user can run, how we can protect the users not to basically be a little bit silly or stupid and run those executables and get their PC compromised. And if these things happens that we see these exploits, we see this bad stuff, we need to be able to collect the information for you guys, for basically forensics, so we can show you what happened, what was the thing we blocked. And the interesting part there is that if you check, for example, that some virus was blocked, nobody knows that why that virus was sent to you. Was there some reason? Were they after some information that you have? Which means that they probably will try another mechanism, another way to basically get that information. What we can give you information is that what the file would have done. So basically we can run the file, give it the information, what it would after, where it came from, and give a context for that information. So you can basically think and you can figure out what is the information it was after and maybe protect that better. And really important thing when we are talking about the endpoints, when we are today talking about the laptops, but when we are talking about also the mobile devices in the future, is that we cannot cause any harm to the user, we cannot have a huge footprint, we cannot have a huge CPU impact. Especially when we are talking about, for example, mobile devices. If we are using a lot of CPU, a lot of memory, it means that the battery won't even last for 1 day. And the users won't like that, and the user don't use it. So it must be really, really lightweight, scalable, so we can use it, we can easily deploy it, easily manage it from central point. And like I mentioned, that when we are doing something like this, it must integrate with the current network solutions we have on the network side, what we have, the current firewall. So they must be able to integrate, they must share information. So whatever happens on the endpoint, the firewall must be able to basically react to that information. Maybe block it, maybe control that traffic. So these are the 5 things we thought that must be done by the endpoint product. So what we did was that we started looking for different solutions. That there's several different solutions in the market. One is the signature-based. Then we have the sandbox-based programs that basically run sandbox on your system. But the problem is there's a different problems. One is the performance. What is the CPU impact, etc., etc. But our approach was that rather than focusing on the vulnerabilities, so we are seeing a lot of those vulnerabilities, we are seeing thousands of new vulnerabilities per year. So we are not going to go after those. So it doesn't make sense because then you are always running behind. And if there's a vulnerability that is not known, well, it means that we wouldn't have a protection for that. So rather than going that path, our solution was that let's see the exploit techniques. All these thousands and thousands of vulnerabilities, all these exploits, they have to use some mechanisms in the actual endpoint. So what we are actually doing is monitoring those, or creating these traps to these exploit techniques. So meaning that we don't have to have any signatures, we don't have to have any updates, and we are able to block all the unknown. I will show you a little bit later how to do it. On the malware side, what we can do is that not concentrating on the malwares. Like say that what we are seeing is on the threat cloud, for example, we are seeing roughly 1 million files per day and a lot of malwares from there. So it doesn't make sense to build a signature, all of those, try to update those to the endpoint. No. Once again, we were checking that what are the malware techniques, how the malware takes the control of the device. There's a different toolkits, tools they have to use to get the control. We are basically blocking those mechanisms. So it doesn't matter if it's a known or unknown, we can block it from the first time. On the exploit side, what happens is that there's these exploit techniques. This is one example of quite new exploit. This is, you can see from the CVE that it's from 2014, the name Clandestine Fox. This particular exploit used basically 4 different exploit techniques. So the idea is there that user goes, for example, to some web page. Then from the web page, the exploit will use the first technique. And the first technique can be, in this case, it was heap spray. Heap spray means that it plays with the memory. It will basically throw this information to the memory to some particular place in the memory. Then after that, the next exploit tool will use the memory, etc., etc. So in Clandestine Fox, to get the control of the laptop, control of the device, to basically be successful, the exploit has to use 4 different exploit techniques. So basically, these exploit techniques. And like I showed in the previous slide here, is that there's roughly 2 to 4 new exploit techniques per year. At the moment, we know there's roughly 23 different exploit techniques available. Heap spray is one of them. And like I mentioned, there is that we are seeing roughly 1, 2, or maximum 4 per year. But it doesn't matter that if there's some brand new exploit technique now available, and the new malware uses or exploit uses that one, because it still has to use the old ones. Not a single exploit can exploit the machine using one exploit technique. It has to use multiple. It can't be 2, 3, usually it's 4 to 5. And we are monitoring all those. So it could be that there's some brand new one we don't recognize yet, but we recognize the second, third, fourth, fifth. So we can block it at any stage. For the exploit to be successful, it has to be successful in every single step. We can block it at once, and it's basically blocked. So it doesn't matter if it's a new, if it's an old one. It's something that will basically be built in next year. It still has to use those exploit techniques, and that's the stuff we are basically waiting for, and then we can block it. When we're talking about the exploit techniques, there's roughly 4 different categories we can say. There's the algorithm, memory traps, logic flows, memory corruption, OS functions, and so on. So basically the idea is that these are the 4 core buckets, you could say, that all these techniques fall in. But there's 23 techniques at the moment we are basically monitoring. So how it works in real life. I will show you a video after this one. So the idea is that user goes and opens, for example, a PDF file. User goes and opens a Word document or goes to a website. When we see that the process is started, the process is in this case Adobe, it can be the web browser, it can be the Office or the Word document. The traps seamlessly inject itself to that process, meaning that that's the only stage when traps is using any CPU. So we are not actively scanning the laptop, we are not doing any scanning there, so we are not actively doing something. The only moment we are active is that when a new process is started up, we are injecting ourselves into that. So no matter if the actual exploit happens 5 minutes after the process is started or 3 hours, we are there waiting. And we don't have to know anything about the actual exploit because we see those toolkits, 23 of them. When we see that there's something happening, we can block it, stop it basically, get the information. The user is safe, but we can upload the information to our management console where we can see what happened, why this happened, and really detailed information. So how this works in real life. Here's a short video how it works. So you can see that on the right side there's a Kali Linux, which is probably known for all of you. It's basically a tool the pen testers and the bad guys can use. On the left side we can see a Windows machine. You can see a Windows 7, which is a target PC, meaning that this is our PC, this is our user. We show that we run on the Kali Linux. It can run somewhere on the internet, and it's basically we starting the process that's listening these connections. On the endpoint on the left side, we will show that it doesn't matter what is the actual AV solution there. We are showing that this particular PC has an antivirus running there, all the antivirus features enabled, all the features the, let's say, the basic AV has. Now what happens there is that user gets an email. It's a HR people, so it's a CV for some job position that's open. But sees that the user opens the Word document. What will happen there on the bottom left corner, you will see that it will run to 1,200 pages. At that moment, the exploit is run. So you can see that what happens, the exploit is run. The exploit will use those exploit techniques, take control of the PC, connect to the Kali Linux, and we have full control of the device. So the user is still browsing the Word document. He or she didn't notice that anything happened. But in the background, it connected to the cloud, and the bad guy has a full control of the device. So now we are showing that what we can do there. So of course we wouldn't be running some notepads or calculators. We would be collecting information. And like I mentioned in the beginning, that if we are information that's in the data center, if it's in the cloud, we hop through the user, because now we are in the user PC. We are in that network. Now we can access the cloud easily. Now we can access the data center easily if we don't have those prevention mechanisms in place. But you can see we have full control of the device from the Kali Linux at the moment. And the user doesn't realize that something's happening, or neither does the actual AV that's running on the device. It doesn't have any clue about this. Now what we're going to do is we're going to install our endpoint agent, which is the traps agent. So this is basically live installation. We don't have to update it because we don't have any signatures, we don't have any databases. What happens is that we have those protections for those 23 endpoint, those modules, those exploit techniques, and we are only bringing the that technique. And basically what happens is we install, and after that, whatever process you start, the traps is injected in those processes and monitoring those exploits if the exploit tries to do something. Once the traps agent is installed, this can of course is an MSI package, so it can be pushed from using Windows tools, AD tools, so you don't have to manually install it. So it can be silent installation, silent rollout for customers. So we are just showing here, now we have the exploit modules enabled, and now we are opening the exact same file again. And now we see what happens when that actual Word document is still open. The Word document seems to be just fine. What happens that when the Word document runs to the page 1200, it will once again try to use that exploit. So it will run, use the vulnerability, use the exploit, and tries to take the control of the device. On the right side, you can see that the Kali Linux is there on the net waiting for connection, that we can get the user connecting. What happens when we see the exploit? The traps agent will block it. It's basically blocking it from the first time. We haven't never seen it before. We can block it for immediately. So the user is safe. We give the user information why we did something, that now we are collecting the information, memory dumps, all the information about the agent, what the actual malware tried to do, and we can upload that information to our centralized management. So you can see that as an administrator, you have visibility what's going on in your network. In this case, this one only has one basically client connected, so it's not that sexy. But you will see that, okay, there's the information. The agent uploaded the information here. We can get detailed information, and we can actually see from here that what was the endpoint module that blocked it. It's here, it's the EPM UASLR. So it was that module that the exploit tried to use for the first time, and it was immediately blocked using the UASLR. So that was the protection we used to block this one. If it happens that this is, for example, false positive, or you don't want to block it in this way, let's say that this is some of your own applications, your own code that's not actually working as it should, so it's taking some shortcuts, and we are checking that it's actually using these exploit techniques. We can easily make an exception. We can say that for this WinWord process, don't care about the UASLR module. We will create the exception, push it to the client. You can see from here that the client now has that exception. Now when we open the same file again, what will happen is that the exploit once again tries to use that same technique the first time. We last time blocked it using the UASLR module. Now we basically let it go through. We don't block it there because our policy says that don't care about that. Don't block it in that module. So when this one runs to the 1200 page, it tries to once again use it. What happens? It will go through the first module, which in real life could be something that we are not aware of. For example, one of brand new exploit techniques. But what the traps will do, because we see that it has to use multiple techniques. Using the exploit, just using one technique is not enough. So in this case, we can see that the next module we blocked it was DLL. So basically, this exploit was using first UASLR, then DLL, then third, then fourth. Different, basically, these exploit techniques. And we can block it at any stage, without any signatures, without any knowledge about that before. So it's a completely different approach, not using signatures, but basically concentrating on these exploit techniques. When we are talking about the malware part, the malware was the part that the user is running something. So the user is basically getting that executable, taking that file, and running that file himself. So what we can do on the malware side with the same traps agent is basically we can create different policies. Like I said, that easy way to bypass the firewall and any network security device is the USB stick. So what we can do is, for example, control that who can run executables from USB stick. If we do that already, already, nobody can basically run the malware from the USB stick. That's just one way. We can create policies how the user can use external medias, etc., etc. Then what we can do is for the wildfire inspection. The wildfire is our threat intelligence cloud, which is doing the analyzing, getting the information from customers that are using the wildfire. So like I said, that per day we are roughly getting 1 million files. So what we can do that if the user gets that executable, for example, from that USB stick, if it's allowed to user to use that one, we can compare in milliseconds if that executable is something we know already, it's a malicious, and we can block it. So based on basically information, if we've seen that before. Later on, there's more and more features added to that one. And the last one is basically checking the mitigation of techniques. So basically seeing that if the malware, like say that for the exploit there's 23 techniques it used, for the malware there's a couple hundred roughly. So we are monitoring those and seeing that we know that malware behaves like this. It could be that it's doing something for the OS, some like this stuff, and we are able to block the malware. So we can basically provide the protection for both, for the exploits and for the malware. In this case, you can see that user tries to open executable. First, we check the policy. Can the user run the executables at all, for example, from the USB? Then we can check the hash against the wildfire in real time. Have we seen this file before? If we know it's bad, we can block it at that stage already. And at the last stage, if the user is able to run the file, they had a permission for that, we will check how that file behaves, and once again, based on that behavior, based on the techniques it used, we can say it's a malware or not. And once again, we don't have to know anything about the file before, we don't have any signatures or anything like that. Whenever we are collecting this information, when we are stopping something, we are collecting a lot of information. Like you saw from the ESM, the manager, we collect the information about the file itself, we collect the information about the trap service, what the traps did, what it tried to do, and really detailed information about the actual related to the forensics. IPs, OS version, and like I said, that we can run the file now on our wildfire service, for example, and we know exactly where it's communicating to, what it was, where it came from, etc., etc. So giving you really detailed information, what was blocked and why. Today, the traps is available for Windows operating systems. So if you still have, for example, Windows XPs in your environment, or you have, for example, some SCADA networks which is using these Windows XPs, we can provide you protection. You know that you are not gonna get new updates from Microsoft against some vulnerabilities. There's a known vulnerabilities already available, and there's no patches for that. So we can protect those. If it's a known, if it's something that's figured out later on, we still have the protection because it's using those same mechanisms. We can basically be on the client side, but also on the server. And it doesn't matter if it's a physical device, if it's a VDI, terminal server, thin client, like I mentioned, SCADA, or whatever. If it's a Windows device, we can do it today. We are extending the platform support and the operating system all the time, so we are bringing new operating systems in the future. Today, it's for the Windows. That's the first part. And like I mentioned already earlier, is that the really important thing is the footprint. How small it be, so that we are not basically causing any nuance or any problems for the user, and the users are basically happy with the solution, and especially when we are moving to mobile side, how we can be sure that the mobile device is still active, we are not eating the battery, and so on. Like say that you saw the installation of the Traps agent is quite small, it's only 25 megabytes, and we don't have any huge signatures you need to update. So it could be that this device it's installed is never connecting to any internet service. It's still up to date, it's still running there, because we don't need to have those updates. And the only part when we are using the CPU is the process when we are injecting ourselves to the processes, or when we are collecting the memory dump and that information. The average CPU consumption of the Traps agent is 0.1%. 0.1 if you compare basic ABs from 5 to 10. So the impact is really, really low. And as you can see, we were living side by side with the current AB solution. So you can still use that if you want. So very minimal impact on the user. And rather than showing you some results, internal results, I will show you some more commonly known stuff. So what we actually did was that we used the Traps. We took a Traps agent from 2012. So when it was still under basically updates, and we were still writing the agent, so it's older version, so it didn't have all the protection modules. But that agent from 2012, without any single update, was able to block all the Microsoft critical vulnerabilities and all the exploit against those, every single one, 100%. And you can see all these which are known attacks. For example, Stuxnet. Nobody knew about it, but if you would have had that traps agent there, the traps would have been able to code it, because nobody knew about the file, nobody knew about the any things where it came from, but it still used the same exploit techniques, and that's the strength of the traps. So we can block even though we have never seen the file. All the future Stuxnet have to use these same exploit techniques, and then the traps is able to block it. Well, these are the, of course, the benefits that you don't need to update or patch your laptops immediately or Windows devices. When Microsoft announces new vulnerabilities on Tuesday, you need to run and update all those ones. No, because when you have the traps is able to block those, like I said, known or unknown. There's a lot of benefits. But the last slide, how this fits into the Palo Alto Network portfolio. So the traps is on the endpoint side. Like I said, that we are doing a lot of stuff, and the network part is really important. So we need to have the visibility. So when somebody is saying that application is not important on the network side, that application is not important on the firewall, well, guess what? What is the way for the threat to get in your network? Well, it's using the application. So you first have to see the application, and inside that application, then we can control the threats. So it's a multi-layer. We have to check the applications. We have to block the known stuff. We have all the known stuff we can block already in the firewall. So basically checking the application. We can control the URLs, block the AVs, all this stuff. But it's basically bigger picture. So if you only test sub-functionality like other guys have been doing, that they test one feature, they enable the AV and say that the AV is not able to catch all the stuff. Yeah, that's true, but we are talking about the bigger picture. It's AV, it's IPS, it's application, it's URL. And when they are all working hand to hand, you get a better result. So on the endpoint, we are doing stuff. We have the threat intelligence cloud, where we are seeing the unknown stuff, we are analyzing things, and now from there we can provide the protection. But now when we have the endpoint there as well, so now when we see something, for example, on the endpoint, some new exploit, we can take that information and basically build protection to the network. If one of our customers is compromised or their endpoint sees something, for example, they are compromised using the USB stick, we see the endpoint blocking something. From that file, and we can analyze, we can see where it came from, where it tries to communicate, what sort of basically a command and control it's generating. And now from the wildfire, we can provide protection to the network level. And we are talking about that we can provide the protections either in 5 or 15 minutes from the wildfire service. So it's really fast. So when we see something for the first time, in a couple of minutes, all the customers are protected already on the network level. So it's really important that these are not silos, that we have a firewall here, we have an endpoint here, but they are going hand in hand, sharing information, and that's the strength, that when all these components are working together, you get the best results. But if you only use one of the features and then run some tests, of course you are not getting the best result, because if you just enable one feature, it's not enough, because we need to have all those functionalities, all the tools, and then you will see that it can block anything, or most of the stuff. So that was introduction to the traps. Like I said, the traps is something completely new, something brand new stuff that there's no similar anybody else available. Anybody else has anything similar available. So we are focusing on the exploit techniques, not the actual signatures. So the approach is completely different. No updates, not like that. Once you install the traps, you are basically safe. Nobody can promise 100% security from now to the future, neither do we. If somebody does that from the security side, it's basically they are knowing what they are promising. But we can say that we can provide you really good protection, and like I said, that the track record is really impressive. So every single exploit from 2012 to today, the traps was able to block. And if you need more information, just either contact us or the Santa Monica guys. They they have information about this. They can basically provide, if you want to test the solution, it's doable. It's really easy to basically build it up, have an evaluation license, etc. Thanks.